Hi all, so welcome to this channel, and in this video session I'll be discussing the IFS C API, that is a write API. So we'll be discussing this API in RPG AS400. So this time we are going to write some data into the IFS file, that is a stream file. So I would say that this API would write the bytes to the stream file or bytes to the IFS file. Just because I would say this because we not only write the characters or alphabet uh, or numeric characters or data structure, so we can write even anything what we want using this API. So that's why I would say that this API would write bytes to the IFS file, that is the stream file. So we can use this API, that write API within the RPG program to write the data into the IFS file which we have opened. uh, so let's discuss about its prototype. So if I would say this is the prototype for this API, and we can see the first thing is an int, that is an integer. So this is the prototype in C. It means that it returns an integer, that is a signed integer, and this is the name of the function, that is write function in C. This is the first parameter, the second parameter, and the third parameter. You can see the data type is different for all of the parameters. So first thing is integer file ds, which means that uh, it would be the file descriptor, which is basically returned from the open API. So before writing anything to the file, we must have opened that file, and when we open any file or any number of file, we have file descriptor returned with respect to that file by the open API. So we need to pass that file descriptor here in the write API, so that this API understand in which file I need to write the data or which file needs to be written. So this parameter serves that purpose, that is it actually tells which files uh, has to be written. Has to be written in which file on the IFS. So file descriptor tells that this file has to be written. Another thing is const void star buffer. Const means we cannot const in C or RPG, if I would say, that means we cannot change the data if you pass it as a parameter, so we cannot change that data. That's the only sense it makes. But another thing is void star buffer, which means we can pass a pointer to the pointer which is pointing to void. Void means nothing, so nothing, not nothing. Let's say we would say anything, so it's pointing to anything. So anything could be a character, a numeric data, or anything else, data structure, or let's say the bytes. So we are referring to the bytes here. So basically here we are passing the bytes which has to be returned. So that's a pointer, so we need to provide the address, starting address of that uh, bytes to be returned. The next thing is size underscore t n byte. N byte means number of bytes, so number of bytes has to be written. So this parameter tells what number of bytes has to be written. Now size underscore t is the user defined data type in C, which is defined in the sys types. uh, the size varies from system to system, so that's why it is defined in the copybook there. What we did here, we took this as 10 unsigned 10 digit unsigned integer as defined in the header files in the C, that is sys type. So this is the number of bytes which needs to be written. So what we do here is we are passing the file descriptor, which files to be returned, the data to be returned. Data is the pointer to the bytes, and this is the number of bytes to be returned. Now what is this? So this is basically the return integer which tells how many bytes has been returned to the IFS file. So it basically returns that number. So if I am trying to write this much number of bytes, let's say 500, and it returned me 400, it means we have not fully written the data. There is some issue in writing the data using this write API. That's why we are getting this number less than this size. So we can check that. I'll be telling you how we'll be doing this. So I'm not going to explain the open API here because we have already did explain that in my, or we have already have seen this in my previous video where I am explaining how we will be opening and creating the IFS file using C API. So there we are playing with the decimal or the binary things. We are understanding what we are doing actually. So you can watch my video of opening and creating IFS files using C API to better understand this video, because there I explained about how we'll be creating or opening a file on the IFS in depth. So in this video I'm going to only target write API. So I won't be explaining this open again, so you can have it here. I'll be giving you the link on the right top corner of the video once you're watching this. So let's start with the demo. So I have already written one source just to work member PDM. Just wait for some time as system is very slow. Now this is my source code. So if I would say that this is the open API, which you can have referred from the previous video, but in short, in brief, I would tell you this is the input parameters of the open API, and this gets returned from the open API. That is IFS path, a string of 32 bits, O flag, that is open flag, and 9 bits a mode, that is of security, and this is the code page, the CCS ID, and this will return me file descriptors. So the open flags are defined here in the form of constants, which you can better understand by using binary or converting them to the decimal using by seeing my previous video. I'm not going to explain all these things here. This is the mode flags, and these are all the parameters which I'm going to send into the and get returned from the open API. So if you see what I'm doing, I'm evaluating the IFS path, then I'm making O flag here that I want to read and write this file, and I want to create this file if it is not exist on the IFS this thing. So let's check if it is exist or not. Workly, I'm checking here, it's not exist, so it will get created, and we have a read and write access, so we can open it on for writing, or we can open it for reading as well. Now the mode is read owner, write owner, execute owner. So the owner of that file who is going to create this, like me, I have all the authorities. I can read, write, and even execute, change, anything I can do. Now I'm running the open API, so I'm passing all these parameters, IFS path, flag, mode. So it will going to create that file, and it will then open that file also. So we'll get return a file descriptor. If it's not less than 0, then it means file is not opened or not created, some error there. Else otherwise it will come here, and then it will going to write this. So let's talk about the write API. So write API now have 3 input parameters which needs to be passed. There is no optional parameter. All parameters are mandatory. First parameter is the file DS. So file DS, I would say, which is returned from this API. So this API would return 10i0. That is a file descriptor. As you can see here, this file descriptor is returned from the open, and once it is opened, we'll pass that file descriptor to the write API as first parameter. So we actually pass this file descriptor, which tells which files has to be written, which file is being opened currently. Buffer, I would say here that it's a pointer to the void, means pointer to anything. So we are pointed to bytes of data which we are going to write onto the IFS file. All things uh, would be value here, okay, and number of bytes would be number of bytes which you want to write, that is an unsigned integer 10 u0. Now these are the three input parameters which we can pass to this API, and we will expect one return parameter from this, which is a 32-bit uh, number. 32-bit. Why I am saying this? Because we will be getting some decimal number, that is the number of bytes which we have written to the IFS. Let's say we have 500 bytes and we have written 500 bytes, so we'll be receiving 500. If we have written 400 less than 500 bytes, we'll be receiving 400. So actual number of bytes which gets returned to the IFS is returned here, and that's denoted 32-bit binary, and we can convert it to the decimal as well. 32-bit binary, I would say, if you are getting, let's say, uh, 1, then it means first bit is on. We are getting 2, it means second bit is on. So like this we are moving forward, and we'll be getting some bits gets on, which tells me that this number of bytes gets returned when we convert that binary to the decimal. So this is the write API, and here we can see we are evaluating some data in the IFS data parameter, which is for write API, and return write. So this is in return. Here what I am doing is I am returning that number of bytes which we have returned to the IFS file. So write file descriptor, passing the file descriptor which is returned from the open API, and then passing the pointer to the data, IFS data. So IFS data has data uh, which is in the form of bytes. So now we are passing the address of that, and then here I am passing the number of bytes to be returned. The number of bytes would be is the size of that IFS data. So if here the size of data is 500, so we will be writing 500 bytes. Now it will return me whatever number of bytes returned to the IFS. So if return underscore write is less than percentile size IFS data, means we have written less data on the IFS, it means some error, so I am displaying that error. Otherwise I am not doing anything. So let's save this and let's compile this. So you can see we are having this program object now, SDODSP PGM. There are no procedure as of now here, but we are calling some external procedure or external program in the form of procedure prototype call. So let's debug this. strdbg API underscore write. Let's set the breakpoint at line number 1 and call this API underscore write. Just do shift F9 and do work link to see whether any file is there. There is no file named open file 1. Just do F10. IFS path is this. O flag is read and write and create the file, that is 12. So we are passing 12 here. So you can see read write is 4 and create file is 8, so that is 12. Mode is all, for the owner. So mode value gets passed as 448, which you can refer from here. So adding all these things, we are passing that. Now this API got executed and file descriptor is returned, which is 0. So for this file it's 0. Let's say if we are opening more than one file, let's for next file it would be 1 or 2, like this. So that is incrementing for every file. So it's 0 now, which means the file is being created and opened. Just do work link, you'll see open file 1. So we can see this file is opened now, created and opened now. That is a stream file, and we are not going into return just because it's 0. It's not less than 0. If less than 0, it means it is not created or opened. If it is already created, it's not created or opened, means some error in opening that file. Now this was the data. Let's see what the data currently in that file. There is no data at all. Now this write underscore return will pass the descriptor, that is 0, which tells this that open file 1 is opened on this path. This is the IFS data, so I am passing the address here, and this is the size of the IFS data. So let's see, if I would see that the size is 500 for that IFS data variable, and I would see return write is currently 0. Now just take F10. Now return write is 500, which means that this is equals to this size, which is 500. So there is no error. All the data gets written successfully into the IFS file. So if I do ndbg and perform work link and just go here, you can see the 500 length of data is being written to the IFS file, open file 1, and since this is not 500, after that you can see some blanks here which got inserted. So if we want to, we don't know for the blanks would get inserted, we should write them in percentile trim, and we would pass the percentile size using the percentile trim first. So that we can do. So that's what we learned from this video. Now we have a command over opening, creating or opening of IFS file, and we can write the data onto the IFS file. Next video would tell you how you will be reading the data from the IFS file. So just wait for that video. Thank you and have a nice time.